Have you ever considered that every piece of equipment you use has been designed by someone? From the tools in your hands to the machines you operate, each one is designed with a purpose. And the processes used, whether to generate electricity or create fuels and other products, these have also been designed. But even highly automated processes require people, often using tools and equipment to carry out tasks such as monitoring, maintenance, lifting, and loading. Without people, the organization can't function. But how are these tasks defined? And how do we make sure they can be done safely and efficiently? Imagine a common task, loading a fuel tanker. This involves several steps, some of which are critical to ensuring safety and efficiency. Just as we design equipment to be user-friendly and goal-oriented, we design tasks to achieve specific objectives. Task analysis is a technique that helps us to design or redesign tasks and equipment by breaking down complicated tasks like loading a fuel tanker into more manageable steps. We can use task analysis when designing new plants or processes to plan the activities people will need to perform. In our example of loading a fuel tanker, we consider steps such as positioning the tanker, connecting hoses, and monitoring fuel levels. Task analysis allows us to imagine how the task is to be done, and we try to design these steps to be as efficient and safe as possible. However, sometimes in practice, tasks are later found to be harder to perform than imagined, prone to human error, or no longer performed how we imagined. For instance, if we find that connecting hoses is frequently done incorrectly, task analysis helps us understand why and how to improve it. We often start with a procedure that describes the task as it's imagined to be performed. Then, we involve the workforce in a walkthrough and talk-through of the task, so we can observe how it is really done. Using this more complete understanding, we break the task down into steps and display this information graphically. For loading a fuel tanker, this might include steps like checking safety equipment, verifying load configuration and fuel grade, and ensuring hoses are connected to the correct compartments. We can use the information gained from doing a task analysis in several ways. Firstly, we can identify staffing and training requirements, ensuring that workers receive the right training. For example, operators might need specific training on handling hoses or monitoring fuel levels. Secondly, we can write or rewrite procedures. This ensures that the procedure is clear and easy to follow, and actually reflects how the task is done by operators. Lastly, for critical tasks, where errors can lead to major accidents or serious injuries, we can perform a separate human factors analysis. We examine each step in the task, identify potential errors and the circumstances that make those errors more likely, and propose improvements to the task, the equipment, or the working conditions to reduce the likelihood or consequences of error. In loading a fuel tanker, this might involve assessing the risks of loading the wrong fuel type, which may be controlled through improved training, updating procedures with additional checks or warnings, or color-coding hoses. Alternatively, the consequence of getting it wrong may be so severe that the risk of error should be eliminated completely by using different nozzle designs for different fuels. These are just a few of the ways that, by understanding and improving tasks through task analysis, we can enhance safety, efficiency, and overall job satisfaction. So what do you think? Have you ever been involved in a task analysis? What improvements were made to the task as a result? Can you think of tasks that are challenging or done in challenging circumstances? Or where the procedure doesn't reflect how work is done in reality? How could a task analysis help improve these tasks? Thanks for watching.